trunk, new branches are split off for every major release. I didn't start at the beginning. The beginning of this all is FreeBSD 2, not 1. 1 was a different story. I picked up at 4 because there's something to say about 4. And you see after 4 we now have branches up to 9. On every branch there are releases, 0 to 4.11, 5.0 to 5.5 and so on. And I think not really in the beginning, I think it's a mistake in my picture, but at some point in time the project decided that for every release that comes out we start another sub-branch, a small one, in which we only apply critical fixes, security fixes, and they're reflected in the release, in the version number as a patch level. Terminology, current refers to the trunk. Stable is a branch which is split off. The stable after the 0.0 release. 0.0 of course is still a release with a lot of new stuff, and do not expect 9.0 to be as stable as 8.3. Although if you compare to some proprietary software sold for a lot of money, then the stability of 0.0 releases is not that bad. Other terminology you'll find in FreeBSD is the RHEL-N or release engineering. RHEL-N-X is the name of such a branch. I've highlighted RHEL-N 9 here for you. And RHEL-N-X stands for Y is a small one, a security branch like 9.0. Before a release comes out, the branch is split off and put into a pre-release state. So people living on a branch, instead of using exact releases, see that we are in a pre-release stadium. And then at the release point, we first get 1, 2, sometimes 3 or even 4 beta versions. This is still the area where a lot of rough edges need to be cut and made more smooth. And after that we usually have 1 or 2 release candidates. I have seen 3 at some releases, but I think 2 is the standard. And a release candidate differs from a beta in that it's, well, released as if it were a real release, including ISO images. And there is a lot of whistleblowing about the new release candidates, inviting the community to please test it and find the last few bugs before we go live. And then we finally get the release. FreeBSD is heavily tested by the developers, but the developer community is just a few thousand people, and we are not all testing all individual areas that have changed. So it's very important for all of you and everyone who uses FreeBSD to grab these release candidates and actually install them and see if it works for your application. I see a lot of people complaining after a release has come out, my application XYZ doesn't work correctly, or I found a bug in this driver, or whatever. Yes, the bug has been there when the release came out, because nobody found it. And if nobody is testing it in your environment, you will not find it. Apart from that, snapshot builds are created every month or so, both of the current branch and of the stable branches that are still supported. They're put on a different server in the FreeBSD project, but it's not too difficult to find. And if you don't want the hassle of doing all the checking out of your repository yourself and compile world and everything, you can grab those snapshots and take a look. It's a community project again, and the more people look at it, the more people report the problems they find, the quicker problems can get solved. Now, what is the decision to split off one of the new major release number? There's only one important rule, I think, and that's if the API or the ABI between userland and kernel changes. Or, in other words, new features being developed in current can be backported, the technical term is MFC, merged from current, into a stable branch and appear in stable release, only if no ABI change in the kernel is required. If you want to do something completely new as a developer, you are allowed to do so in current, but it will not see the world, or not the world outside the developer community, until a new release is split off. FreeBSD project guarantees API and ABI stability within a release. And I think that's quite important, and it's very clear if I compare to another open source operating system where you have to look for kernel 16.34 if you want a certain feature. How am I going to remember all those minor version numbers? Yeah, it's quite simple. If it works on 8, it works from 8 to the upcoming 8.3. 8.3 is not out yet, it's in pre-release now. And hopefully it will come out in 1 or 2 months. Sorry?
Release Schenkeveld 1 is
RC1, sorry, yeah, RC1 is out, pre-release is on the branch, and RC1 is the release point at the moment. When a release is about to come out, the release engineering team in the FreeBSD project takes ownership of the repository. Heads up are sent to various mailing lists to notify developers of the upcoming release. There will be a certain period in which the repository will be more or less frozen. You are not supposed to do major stuff in the repository unless the release engineering team approves, and the release engineering team can settle the dust and work towards the new release. Then after the release candidate 1 is tagged in the tree, the tree itself is unfrozen again, and developers can go on and do new stuff. So eventually, after some betas, release candidates see the release, and when the release happens, it's handed over from release engineering to the security team, and the security team takes care of further maintenance, which means after 9.0, which has come out, we only will see critical fixes being applied, which will be 9.0 P1 and P2 and P3, the patch levels. Not much more will go on in 9.0. In 9 stable or running 9, you'll see new things happen all the time until 9.1 is about to come out. How long does the security team take care of a release? Well, there are 3 kinds of releases. There's the early adopters. I believe some, but not all of the 0.0 releases are marked early adopter, and they will be taken care of for 6 months after release. Most of the releases are, well, many of the releases are normal releases which will be supported for at least 12 months after release date, but also at least 3 months after, at least until 3 months after the next stable release comes out. So you will always, as a sysadmin, have at least 3 months to upgrade your machines if you're running on normal releases. Well, for a lot of companies this is not a good model, they just want a longer period of stability, they don't want to be forced to within 3 months replace all their or upgrade all their systems because of a new release that comes out and the old one going out of support. So that's where certain releases are marked extended releases. They will be supported for at least 24 months and at least 3 months into a new release that is also marked extended. So if you want to use FreeBSD for your business, you can just hop from one extended release to another. And I've marked extended releases with red here. So 7.1 is an extended release, 7.2 is a normal one, 7.3 is extended, and 7.4 is also extended. The reason 7.4 and 6.4 and 5.5 are extended releases is that the decision was made that the last release that comes out on the branch will automatically be extended to give people as much time as needed to plan the migration of your systems to a newer release. So this is in general the release model. We are now, the rest of this talk, we're talking about 9.0, which came out in January, as I just said. But the release model, because it's not well understood by some people, I think was just worth mentioning for a while. So what's new in FreeBSD 9? Well, as always, we get security fixes, we get bug fixes. There will always be new device drivers or enhancements to existing drivers, supporting more modes of your Ethernet interface, for instance. There are network stack enhancements, but this is all very vague and general. Let's look a little bit closer. Unfortunately, with every release, we also get a couple of new bugs. That's live in the software world. So again, please help the project, send in problem reports, use the same PR script which is installed with FreeBSD. And if possible, if you know the fix to your problem, send it with PR and help the project. The first thing that will be very, very visible when you start playing with FreeBSD 9 is that BSD install, the old installer that we have been using for ages now, has been replaced by a new installer, BSD install. Sorry, it says install, the old installer is completely replaced by BSD install. If you look at the manual page of sysinstall, it says in the bugs section, well, I think can't be put more clear than this. It was just a prototype put together by Jordan Hubbard somewhere in the early 90s, just as a quick hack to get release 2.0 out. There has been a lot of work, I think some 10 years ago, there's been a lot of work done on a new installer, which was very ambitious with separate front and back end, so you could run it with a ASCII user interface or with a semi-graphics or with a real graphics interface, and more user interface could be added, but the project seemed to be too big and too ambitious and slowly died. Well, with FreeBSD 9 we finally have a new installer, and what's different with sysinstall? Why did we need this install? Well, sysinstall itself was written in C, and as a quick hack, well, it's not that bad if you look at the code, but still it's not easy to implement new stuff with every release. So sysinstall is far behind on features, can't install on modern file systems, as we'll see later tonight, and it's just a dead end street. The new installer is written as a shell script using the dialog program to communicate to users, but as a shell script it's much easier to enhance it with new features and keep it in sync with what happens in the operating system. It's more modular, and for instance adding new file systems is much easier now. One part of it is missing, that's the configure submenu. You can set the root password, your time zone, add users, do your network configuration and so on. That's why in 9.0 sysinstall is still there, so you can use the configure submenu of sysinstall to do all the installation tasks if you don't want to edit your password file and your rc.conf and so on using a normal editor. But I've seen that Testy is working on a program called BSD config. If you look at the hackers mailing list, there's quite a thread going on about this program right now, and most probably this will fill the gap in future FreeBSD releases, be a companion to BSD install for all configuration tasks. And then we'll have all the functionality back and a lot of new stuff. Right, what else is new? We start with the kernel. Capsicum is a new subsystem in which applications can be completely sandboxed and all kind of things applications can do can be enabled or disabled per sandbox. It can also be used in existing applications to make sure, for example, that your web server cannot write to your file system anymore, except for sending log messages. So if you want to make sure that even if there are bugs in your popular Apache or whatever Nginx web server, that even if people break out, they still can't change your document tree. You can sandbox it and make sure it cannot write to the file system just because the write system call doesn't work anymore. Who has come across pfill? Pfill is a hook brought into FreeBSD some time ago as a generic hook to connect packet filters into the kernel. You all know we once started a long time ago with IPFW, and then a couple of years later we got a second packet filter called IP filter by Darren Reed. That was quite popular at the time, but it's not well maintained anymore, and there's a little license issue with it. So we got PF over from OpenBSD some years ago, and that makes it 3 packet filters now. PF has some other issues because OpenBSD is more and more different from FreeBSD if you look at the way the kernel works, and OpenBSD doesn't support multiprocessor that well, so good chances that PF is not our last packet filter. We'll have more packet filters in the future, probably NPF, which is written from scratch. In the NetBSD world, can be imported at some point, looks very promising. pfill is just a generic hook so that packet filters can register themselves without the developer of the packet filter having to trigger all kinds of routines in the network stack to get it connected. Well, that mechanism has been generalized into a new mechanism with 2 entries, khook and khelp, where subsystems can hook into existing parts of the kernel, and not only for the packet filter, but for all kinds of things. So if you want a new scheduler or you want a new timekeeping or whatever, it can be plugged in, provided that there are hooks available. But we'll see more and more subsystems in the kernel in the future throwing hooks that can be attached to by new subsystems, and that should make it easier in the future to add functionality without too much changing existing code and patching existing code. Another very exciting part is resource accounting and resource limiting. Resource accounting is enabled by RACCT in the kernel, and there's a utility RCTL userland to work with it. The basic idea is that you can restrict all kind of things like memory usage or processor time or whatever for a process and its descendants, and it is supposed to work very well with GILs. If you want to virtualize hosts, you can limit hosts not only by the part of the file system that the application can see as it is now, and well, GILs at the moment support separation of file systems, separation of IP connectivity. You are limited to a certain set of IP addresses, but you can still consume all the memory in the system. There are already, before resource limiting came into play, hooks that you can limit the set of processors that a GIL can run on, but not memory and processor time and other stuff. So I think with resource limiting features we finally get a solid basis for virtual hosting, even commercial based virtual hosting like an ISP, running a lot of customers on one machine and make sure that one customer does not kill off all the other ones. Right, soft updates has been in FreeBSD for ages now, since the FreeBSD 4th, I think, so it's more than 10 years. Journaling since FreeBSD 9 is now standard, so if you create file systems using the FreeBSD installer, then you automatically get journaling unless you switch it off. Come back on journaling in the second talk this afternoon. Trim support, that's for SSD and other flash memory, where the operating system can tell the disk or the flash device that a certain page of flash storage is no longer actively in use or actively used by the operating system, and can be put into a free pool so that level wearing can be optimized inside your flash device. Trim support has been added to the UFS file system to make SSDs and other flash devices live longer. We now have NFS version 4 as the default NFS implementation. Version 3, the existing implementation that was in FreeBSD 8 and before, is still there, and you can still rebuild your kernel with the old code if you want to. But NFS version 4 is now the standard on FreeBSD 9. USB 3 is now supported using the XHCI device driver. And we now have a new packet filter for USB, much like BPF worked for IP packet filtering. We can now use USB dump to see our packets on the USB bus, like TCP dump dumps your packets on your network. That should greatly ease the job of developers making applications with USB. Like I've seen the webcam daemon, it's in FreeBSD 8 already. I know that Competa, who's both the author of the USB stack and maintainer of it, and also the implementer of all kind of nice stuff like webcam daemon and other USB applications, is put it in to make it easier to develop these kind of user-led things.
Do you want us to ask questions in between or at the end of the
Yes, you can ask questions if you want to.
I was wondering about the caption that you can, for example, limit a web server that it can write to your document root anymore. Is it possible to do that but still have it be able to write to, for example, a dedicated area where you want to be able to write, for example, image cache or stuff like that?
Okay, so the question is with Capsicum, if you can limit your web server, for instance, that it cannot write anymore to your document tree, but it can still write to like a caching area.
Yeah.
I don't know. I have not used Capsicum myself so far. I've been in some talks by Robert Watson about Capsicum. This is something that I honestly cannot answer at the moment, but no, we have to look it up or ask the long man is.
Yep. Will do. Thanks.
Thank you.
Some nice papers on the BSD Ken website.
Okay.
We presented it last year in BSD.
Well, we had Capsicum and EuroBSD Con in the
As well.
Netherlands last year.
Okay, cool. Thanks.
CFS, zettabyte file system by Sun. We went from version 15 to version 28. 28 is the last version that came out of Sun before everything went over to Oracle. It has a lot of new features. I've just highlighted a few that sound sexy to me, but maybe other people like other features more. We now have triple parity RAID-C, so large, big machines with lots of disks. We had RAID-C with 2 parity drives already, so while a broken drive is being replaced, we still have redundancy because of the other parity disk. We can now extend it to 3 disks. Believe me, you like it if you're running a data center remotely and run file systems with 20 or more disks. We can finally remove a log device, so if you have added a log device to your storage pool, in the past you could not remove it anymore, you had to recreate your pool from scratch and get your data back from a backup, move it from one pool to another, but we now can remove log devices. Another compression algorithm, ZLE, is added. Deduplication, where during write a checksum of every block written to disk is stored in a cache. And if on another write the same checksum occurs, the block is compared to a previously written block with the same checksum. If the blocks are equal, only one copy is stored with 2 references. Why is this such a interesting feature? Well, maybe some of you have pictures stored on your computer at home and you share them with your family members, and they make a copy of the picture in another folder because it belongs to a project they're doing or something they're writing, and before you know, you have 10 copies of the same picture all around on your hard disk. With deduplication, the file system detects that you are writing the same data again and again and again, although it's not directly related. It's not like linking a file. It's a separate creation of a file and writing the same data again, but it's still detected by the operating file system, and it consumes the space only once instead of once for each copy. Well, scrub statistics have been improved a bit. Performance, creating snapshots and deleting snapshots. Snapshot creation and deletion was already quite fast if you compare it to snapshotting on other file systems. But if you run a system with lots and lots and lots and lots of snapshots, like 5,000, 10,000, 20,000, 50,000, and you automatically create snapshots like every 5 minutes of all your data sets and clean them up after several days, it starts to count. We now got InfiniBand support in FreeBSD 9. InfiniBand is a low latency, high bandwidth interconnect that's mainly used in NAS and SAN-like environments where one storage box is connected to one or more application boxes, and you need well, near disk speed performance between machines. Your typical network, gigabit, 10 gigabit, doesn't come into the area of the speed of modern storage devices, and that's where InfiniBand fills the gap. It's not a replacement for network, it's more like a bus between computers. TCP now has a pluggable congestion control framework with multiple algorithms, like the new Reno and Hamilton. A total of 5 algorithms implemented already, but because it's pluggable, it's now easy to add more in the future. Instead of hacking the code again and again and again. There's a lot of code cleanup done during this build of this framework. dtrace, you all know dtrace? Came into FreeBSD from Solaris, where you can monitor kernel and processes on a running system, put in breakpoints and have code executed, do stuff like statistics and accumulation and stuff like that on the fly. It now has new entries so that it can also trace 32-bit FreeBSD and Linux code on a 64-bit machine. Nice new framework, a subtree of the sysctl object tree is the kernel.features tree, where eventually all features in the kernel that can be optionally compiled in or not are visible. I've shown 2 examples like UFS quota and System 5 semaphores. If your application needs semaphores, in the old world you would see your application crash because semaphores were not compiled in your kernel. Your application can now, or even the installer can now, do a little check, are semaphores available or not, and warn you in advance and not wait for the application to crash or just malfunction, depending on the quality of the application. UFS quota to say, in the past you just had to try and set quota and see if it worked or not to know whether it's in your kernel if you didn't build the kernel yourself. Now your application, your installer or whatever can check for you if it's available and not use it or warn you if you really need it when it's not there. Geom has got a few new modules, we'll see that after the break. Network stack has a lot of new improvements. IPFW, the first FreeBSD packet field, still in development. We still get new features like now it also supports forwarding on IP version 6 protocol. I found out the hard way that forwarding worked on IP4 and not on IP6 last year when I needed it. It's now there. And then, again, many new and enhanced device drivers. That's a long list about what's happened in the kernel. Let's go to userland then. Well, BSD install, I've already told you about this. The new bootloader menu with acronyms, and we show its this is the new boot menu. The old menu had numbers 1, 2, 3, 4, 5, 6, 7 to enable ACP or disable ACP or go into single user mode or to reload a prompt, and well, not enough time to do it all before the time to stop it. How do I stop it? Oh, what's that? Oh, gee, I have to press the reset button again. It's now using acronyms like escaping to loader prompt, A to enable or disable ECPI, it's a toggle, safe mode with M, single use mode with S, and verbose with V. They're just toggles. When you press it, you see the value swap, and then pressing enter, you proceed with the boot process. Not a big thing, but some people like it. Right. Where's Ed Schouten? Is he not here tonight? Ed did a lot of work on UTMP. UTMP is the table that holds all the currently logged in users. So if you type who, you in fact just look at the contents of UTMP. The UTMP format was fixed records with fixed field lengths, and if you ever wondered why you only saw part of your host name where from you were logged in when you type who, well, that's because there was not enough space. Other systems already have UTMPX, the new model, for a long time. Well, FreeBSD 9 now also switched from UTMP to UTMPX, so we now can see full host name. So if you wonder from where is this user logged in, you can now just cut and paste the host name and check there without guessing what's the host name, because it's better after 60 characters. We see a continuous movement of FreeBSD towards BSD licensed code. If you look at the source tree, we still have a lot of source files under the GNU subdirectory. And with the GNU world being more and more restrictive with every new version of GPL coming out, we are in desperate need of more and more BSD license codes. The GNU license is contagious. If you compile stuff with the latest GNU compiler, then the stuff you have compiled can only be released under GPL. It's a problem to burn CDs and release CDs under a BSD license if there is GNU stuff on it. So that's why we see iconv. In the past we used iconv with a GNU license from ports. iconv is now part of the base operating system. The implementation was done by the NetBSD team. The same with the readline database, the command line editing, which is in many tools in FreeBSD, is now replaced by libedit from NetBSD, which is BSD license. We already saw in the past that tar and CPIO and diff and sort and many other Unix text processing commands have been changed or replaced by BSD licensed code. And I think that's good. I think that it's better to be pure than to have people warning you, hey, you are using GNU-based code and you should follow the GNU rules. GNU is supposed to be an acronym for GNU is not Unix. Well, maybe BSD should be an acronym for we are not GNU. Right, and every now and then we see new architectures being supported, like the PowerPC platform now supports Sony PlayStation. So now finally we have some good use for that piece of equipment that your child is playing with. You can teach your son or daughter to play with FreeBSD instead of blowing alien ships out of the sky. Yeah, well, that's basically what I wanted to tell about what's new in FreeBSD 9. Of course, you can find more details in the release notes, which you can usually find from the FreeBSD website. I didn't want to tell you all the individual device drivers that have been added or modified. It's a long list, and who cares whether EN now supports that one mode that it didn't support in the previous version, or the IGB interface, or whichever. Look at the release notes. I hope this gives you enough teaser to have a look yourself and start playing with it, or play with BSD again if you haven't done that for some time. I couldn't resist to also tell you a little bit of what's going on beyond 9.0. Stuff that's worked on in current, in FreeBSD 10 at the moment, but you'll see some of it will be ported back to FreeBSD 9, later 9.1, 9.2, or 9.3, whatever. But again, all kinds of fixes and stuff. Nothing new here. We'll move from the GNU compiler to the LLVM compiler framework and the Clang compiler, just for the reason I just told you. We are now using an old version of the GCC compiler in the base system. We cannot move the base system to use the newer compiler just because of the license. We wouldn't be able to release FreeBSD with a BSD license on a CD or DVD anymore if it were compiled with a newer license, or we would be in fault. We always had a C++ stack, the libc and the std++, I think they're called libraries, and they were always GNU licensed. We now have BSD licensed C++ libraries coming up. It will take a little bit of time to mature, but it will certainly replace the GNU-based stuff in some time. Our friend Gern Ziep, he has done a lot of work to make sure that the FreeBSD system can be built without legacy IP version 4 code in it, so a IP version 6 only system. That was not as easy as it looked like. And, well, basically IP version 4 has been there for ages, and I think nobody ever built a kernel without networking, since someone at Sun told us the network is the computer, so we now all need that network. But it was a good exercise, also very good in terms of separating code in clean chunks and make sure that there were no hidden paths between network stack and other parts of the kernel. So we're future ready. By the way, we also did a lot of work on IPv6 itself. It's rather mature now, but since we are not yet all using IPv6 on a daily basis, and we are not yet all implementing IPv6 firewalls and all this kind of stuff, there are still some rough edges here and there, but it's quite mature. I've been using IPv6 and FreeBSD for more than 10 years now, and it's come a long way, and it's good to use. CARP, the address redundancy, or the host failover protocol, has been more or less rewritten by and well, up to now we had to create a CARP interface for every interface that we wanted to fill over, and the CARP interface was only bound to the real network interface by a matching network number. So if you apply the net mask on your IP address, it found the interface with a matching network number and then automatically tied to it. That meant that it was not possible to use, for example, private IP addresses for the CAR protocol itself, but put a public address on the virtual interface. If you wanted to put a public address on the virtual interface, you also needed public addresses on your physical interfaces. The new implementation now makes CAR an option to be installed by ifconfig on every physical interface. I've read about the implementation. I've not yet experimented with it myself, but it looks much cleaner now and gives you a little bit more control over addresses. One point is not yet functioning, that's load balancing, but he's now looking into it, and I'm sure we'll see the world before FreeBSD 10 comes out. And CAR, I hope, is a candidate. I don't know if there is an API change required, but I hope it will be later fitted into FreeBSD 9 at some point. Looks very promising. Well, you all know PKG add and PKG info and PKG delete and PKG whatever, and imports are even more commands to enhance packaging system. But have you ever tried to do a complete binary upgrade of packages without having user ports? Well, that didn't work. Whatever method you used, even with intelligent systems like port upgrade or port master, you still needed user ports, just for indexes. There's new PKG implementation. I think the command itself is just called PKG. It's written from scratch and should combine all the features of the various PKG underscore whatever commands into one tool, and on top of that also allows for a complete binary package management on an end user system. So you now don't have to copy user ports to all the machines. I was working for an ISP last year, and they had numerous FreeBSD machines for lawful intercept. It's tapping your telephone or email conversation on behalf of government. And they had one of these machines in every country where they were present, and they were all behind firewalls. So I couldn't NFS mount ports from one system to the other. So with 20 odd countries, we would have to have 20 odd user port trees populated. It just doesn't work. The new PKG tool, PKG NG as it is called in the mailings at the moment, saves you from all the hassle. You can just bind updates. The geo multipath is rewritten. We see a lot of high availability stuff going on in FreeBSD at the moment. And this is just one of it, where disks are, for instance, in a NAS or a SAN device connected to your host using more than one physical connection, for example with multiple network cards, multiple switches for redundancy, or with InfiniBand with multiple paths. And the G-multipath is a layer that allows you to tell the system, hey, this is just one disk, but there are two ways to get at it. And you can tune when both paths are up. It can use a load balancing algorithm to get the sum of the bandwidth, and when one of the paths fails, it can still continue accessing your disk of the other path. It's great for high available applications. The HD audio driver has been mostly rewritten. And again, we see some new platforms. ARM is still an area that's attracting a lot of more. FreeBSD is getting more and more popular with embedded devices. Maybe partly because of the new license stuff if you want to put Linux on it. And now with a little less than 50 euro access point at home by TP-Link, which is running FreeBSD. That's nice stuff to play with. So this is just a piece of what's going on beyond FreeBSD 9. Some of this will be backported to 9.1 or 9.2 or whatever. Some of it still have to wait for FreeBSD 10 or start playing with it now if you like.
Was the access point factory delivered with the FreeBSD?
No, it was factory delivered with some Linux kernel and stuff and web interface, and I had to open the box and solder 3 wires into it for a serial console, and find myself a little TTL to RS-232 line driver and connect that to my system to get to the console and make it boot something else, being FreeBSD. You can do that just once and then it runs FreeBSD and you don't have to use the wires anymore. So, well, thanking a lot of people who made this all possible, and well, thank you for sitting here and talking to an empty room is no fun. You can find a lot of information, release information at the website, of course. Please subscribe yourself to the FreeBSD announced mailing list if you have not done so already. There are some other interesting mailing lists too, FreeBSD stable, FreeBSD current if you want to know from day to day what's going on, but also people complaining about stuff. If you're interested in particular stuff like networking or virtualization, whatever, there are dozens of lists available. Reading the list is, well, a lot of fun and teaches you about what's going on. These lines to remember that for the next time. It says questions. Yeah.
But FreeBSD was always considered to be the reference stack implementation for IPv4. Do you expect the same? Yeah, IPv4. Do you expect the same will be true for IPv6 now or in the future?
Well, we saw when v6 was being worked on in the early days that there was work going on 2, you could call them reference implementations, a French one and a Japanese one, and FreeBSD has chosen for Kami, the Japanese one, and I think all BSDs have Kami stack now. We have diverted a bit from the Kami stack with a lot of bug fixes. There are some people from the Kami project who are still active in FreeBSD. Kami project itself has closed already. I don't know of operating systems using the French stack at the moment. I think the Kami stack is most popular in general. Is it the reference stack? I hate to say, but the only true answer, of course, is whatever the company in Redmond is using should be the reference, because they're using most of their installed on most devices. But I think most stacks at the moment are very close together, because they're all derived from Kami. Other questions? A bit disappointed because talking to a lot of open source minded people, I was expecting one more question.
Do we know that already?
Right. I think we have a short break, and then I don't know how long we stop. 15 minutes or so.
15 minutes.
Yeah, 15 minutes. You can have a drink, and then we go on with the next part after the break. Thank you.